Welcome back to the channel. This is the E93A rescue channel, and this is part 6, and I'm going to look at the M45G starter motor for these 10 horsepower engines. Several years ago I bought a exchange one off eBay. This is the box, Lucas Exchange, and this is the actual starter. So this is what they should look like. For the 10 horsepower E93A engine. When it comes to paperwork for this starter, I've got some various bits, but the best one by far is the actual workshop manual, and that's the starter there. And you can see that it's got good breakdown of all the parts, and it's what I'm going to use. But there are some other items. There's this Lucas Technical series on starters. Now you'd expect it to have this one in, and if I indeed turn over to this page, which I preview, there is the M45G starter as listed in the index, but it looks completely different. This section here, the gears and the springs are the opposite way round. So it's useful, but it's not ideal. And then there's this one as well, which is the workshop instructions, and again it's got M45G. But it does have useful information like brushes and torque settings and things like that. So these documents are useful, but by far the best one is this one. Right, these are all the component parts. Now, I've had to make quite a lot of the parts because they weren't all available. I had to make this part, the band. I had to make this washer, a spacer washer. I had to make that little thin washer there and that little thin washer there, and I had to do some welding on the inside of this because it had come apart. So these were parts that were basically damaged, and you can see here lots of corrosion where it was sitting in water for many years. Now, to be honest, I didn't think this starter would work when I put it together. It was going to be a junk one. But as you can see, it will work fine. So that bit there goes in there. So keep an eye on the brushes. Best to pop the brushes on the outside there, because you're going to need them on the outside for later. That bit goes in there, and it shouldn't really drag, so that's good. And then the end cap goes on. And then you can put this end on here. Now this is the difficult end to get on because you've got to get the brushes aligned. So you've got to get these brushes pushed back there in order to get this piece on. So the trick is to just push the brush back a little bit there and align the spring just like there on the top, if you can see. I shall attempt to do the same with the other one. Need to get the brush back a little bit. Then just sort of wedge it about there. And then the pressure of the brush pushes down, jams it, but it keeps it away. Okay, so these brushes, bit fiddly. Springs. So the way the springs go on is that flat bit there goes into that joint there, and you can see that very well. Move it around a bit, and then that's sort of nice and flat. Move it up near the top, and then when you're getting these installed, you've got to try and rest that little end bit. Basically, get it positioned such that he says. So you push that out like that, and then you rest it on the corner there. Can you see that? Show you, see that? Rest it there in the corner, and then you can assemble them, and then all you need to do is to ping that spring off, put it back in the middle, and the brush will fit into place. Okay. Right, with both of those brushes pushed back, there's a little dowel piece there, a knob bit, and that fits into there, and now you can actually get that on. So the next stage is to pop the screws through in the right place. Get that round the way. So that locates like that. And the same for the other side. So basically we're going to put the springs back on these two, so we need to get them into the middle section. Just basically pop them there in the middle. That should be all right. So they produce even pressure on the brush, and the same with the one on the other side that we've flipped over, which is this one here. Pull it back. Need be just align it on its post a bit, get it in the middle. Those two are done. This bit can be a bit tricky getting the other two brushes in because they only just about fit. So I found if you slacken that bit off a bit, it gives you a little bit more room. And you've got to do the same thing here. Basically, you've got to pull the spring back and out of the way, and then pop the brush in. Down in that slot there, get it into place. Once you've got it in place, then put the spring back in the central section, and I'll do the other side as well, but I won't film that to save time. Right, that's all the brushes in. I've checked them, they're all lying in about the middle, looking quite good. Adjusted the wires, and you can see there we've got rotation, and we've got a little bit of play there. Probably what, 0.5 millimeter maybe. Now that will cause a problem if you're not careful, because if you tighten all this up, it can jam the rotor. And I'll show you what I've done to fix that. But we can actually give it a test now. I'm going to connect it up to our battery and just give it a quick spin. Direction of rotation is important as well. It's marked on the actual starter motor, and I've put an arrow on there to show it. So if I just test that, you can quite clearly see that it's in the correct direction. Now you might think that if you changed it from positive earth to negative earth, that it would go the opposite way, but it doesn't. So I've now got it rigged up in the negative side to the casing, and I'm going to touch the 12 volts from a battery onto the terminal. Watch what happens. Still goes the same way. So basically you could change the truck to negative earth and still use the same starter motor. Okay, so some of the specifications that I've written down out of the various manuals that are available, as you can see here. Spring force, end float, out of mesh clearance, and I'm going to measure the face of my starter to the back of my flywheel ring gear, and then compare that with the dimensions. So first of all, spring force, 1 kilogram plus or minus 0.15 kilograms. Okay, to measure the spring force on the brushes, I'm going to use this 0 to 5 kilo fishing weight, not particularly accurate, but good enough for the purposes. I've rigged up a split pin, and I thread the split pin through the center of the spring, and then lift until I see it just moving. That's it moving there, somewhere between 1 and 1 1/4, which is absolutely spot on. So end float now, 1.45 millimeters for this. So I've got this set up with a dial gauge, and just over 0.5 of a millimeter. You can see that. So that's well within specification. Right, I'm going to try and measure using this ruler and this vernier caliper. The distances between the ring gear and the cog on the starter. Not going to be easy to film, so I'll just show the results after. Okay, I've taken some measurements now. I've taken the measurement A, which is from the face of the bell housing to the outside edge of the starter cog. B, from the face of the bell housing to the face of the ring gear. And C, the thickness of the ring gear. Do a bit of maths. A take away B take away C equals 2.4 millimeters, which is well within specification, 3 millimeters plus or minus 1. So I would say that this test rig that I've got here with the starter is fine to run, and it has been running fine. So the next step is to set up the starter cog and springs and so on. And you can adjust the position of this green section cog by these washers here and the amount of squeeze that you put onto this main spring. In order to do that, we need to work out that dimension D and then transfer that to the assembly of the starter. So we need dimension E, which is the gap between the back of the bell housing and the front of the bell housing. And that's going to be able to, with those other dimensions, be able to work out what D needs to be within a 2, 3, 4 millimeters. So this is another engine, but should be all the same. So that's the dimension we need there, from that point to that point. And it comes out to be 88.42 millimeters, 88.4 we'll call it. So after taking that measurement, 88.4 millimeters, which is E, we take off A, which we got before, 29 millimeters, if you can remember. That gives us 59.4 millimeters. However, we weren't quite in the center, so we need to make an adjustment. So making that adjustment, and we can be around about 58.8 millimeters plus or minus 1 millimeter. And that should be the distance to set it up. So I'm aiming for basically 58, 59 millimeters. Right, so this is where the book comes in really handy. Because what we're going to do now is assemble these bits here, the springs, the sleeve, the pinion, the spring guide, the pinion retaining spring, and various bits of nuts and washers and things to get that dimension, 58, 59 millimeters. Okay, so first of all, you remember there's a bit of end float there and sitting slightly inside the bush. So if you tighten the whole assembly up, you end up jamming it. So I made a very thin washer that just goes on there. And then there's a spacer washer that's shown on the picture. So that means now that won't jam. And then you pop the main heavy duty spring on. And then there's another spacing washer that goes on there. And then the actual pinion, now you see that's a bit rattly, but that'll sort itself out when we put the next part on. And the next part then is this helical part, which sits inside there, like that. And that's the bit that spins out with the weight. And then there's this little tiny thin washer. I had to make that as well, because there wasn't one. It broke, and I think it stops the spring, this little spring, from jamming inside. So the next part is this little return spring, and I tend to find it's easier to keep it held back, otherwise it tends to sometimes jam. So it's going to sit against that washer there, and then let it go. As you see, it's going to try and fall off. So you need to pop the nut on, should I say. I'll tell you a story about this nut in a minute. And then we tighten the assembly up, and we'll see. And the way I've been tightening these up is to put like a pair of pipe grips on there, and then spin that nut round until it hits the shoulder, and that's it tightened up. This is the correct nut that goes on there, but the threads inside the nut are stripped, and I couldn't find the right size nut anywhere, so I had to run a die nut down here, UNF, 1/2 inch UNF, and it fits pretty good. So that's an alternative if you can't get yourself a nut, is run a die nut round and then buy a castellated UNF nut, 1/2 inch. And I've ordered the castellated nut and it's on its way. Here's another set of cogs and a helix to spin out, and it spins out nicely. However, this bit here is like this bit here, and it doesn't come with this external ring. Without that ring, it doesn't work properly. There isn't enough inertia or circumferential force or whatever you want to call it for when it spins to like throw it out. And when I tried this one, it will sort of go out and then it'd come back again and wouldn't stay out, so it wasn't really suitable. So that's why I had to weld that piece onto there to make it match the original design. So this little very fine spring here quite often seems to break. You can buy them from small Ford spares. They get jammed and then twisted and they jam it up. But really it's there as an anti-vibration spring. You know, when this thing is sitting away and it's vibrating, you don't want the thing to vibrate its way into the ring gear and then churn away. So that's what it's for. So if you remember, we're looking for 58.8 plus or minus 1 millimeter. So there's 60 millimeters. And we are pretty much there, 60, 59. Great. And if we do the same check on the factory made starter, reconditioned starter, again, same place there, 60. So they are around about 58 on this one. So again, in specification. Right, nearly all together. This connection here sometimes starts to get a bit corroded, so it might be worthwhile just to run a nice flat file over it, keep it nice and flat, just to smooth it down a bit. It gets eaten away. And then likewise inside here, this connection here can become a bit pitted with the sparks, so just make sure that's in good condition. And then basically you screw that onto there like that with 3 little screws, and that's what operates the starter. We've just got that. I'll pop that on now, and then there's just the cover plate to go over the brushes, and the thing's complete. And if I had to make this band, because there wasn't one, but I had to make sure there's a cutout on it, otherwise it jams up. And that goes over the top there, you see. So grind that bit away and it fits better. And then of course we need to give it a final test. Okay. And there's the castellated nut arrived. I had to file it down quite a lot, sand it down, get it to fit, but split pin fitted, nut fitted. So that's that starter motor pretty much finished. So the instructions say to oil the bushes. So if it's a new bush, then you're supposed to soak it in light oil overnight, but these are not new and I've already put some oil on them. So I've just pulled the spring back a bit there, but it's easy enough to get some oil into there and let it seep down inside the bush. And likewise at the other end, you can pop some some oil into the bush there. Get it to run around. That's running in there nicely. Let that soak in. So of course the ring gear on the flywheel is also important. This is the spare piece, but basically it throws itself into there, and wear and tear on here. This one's worn. You can see the sort of the bits taken out of it. This one's better, but ultimately if there's too much wear on that, it's not going to engage properly, it's going to slip out. So that's an important factor to bear in mind as well, as is the wear on the ends of these teeth. This is my test rig. I'm going to test the starter motor on this engine. So I'm just going to start it so you can see what it's like, and it's very smoky and very noisy, so I won't talk. Right, that's me changed out the starter on my test rig for the starter we've been using. So a non-start test first of all. That looks good. And then an actual, see if we can start it test. Bit of choke. And again. Thanks for watching. That's the end of part 6. M45G Lucas starter as fitted to the 10 horsepower E93A engine. Thank you.